Okay, so we're going to look at inferential statistics, and when you're looking at this, make sure you have your handout that I gave you on this open at the same time, as we'll be going back and forth between both. So inferential statistics was only introduced to the Leaving Cert Ordinary Level course in 2015. I suppose empirical rule appeared in 2015 on the paper, and it was only in 2016 that they asked margin of error and confidence testing, meaning that this year there's a high possibility that they actually could ask this. So it's paper 2, it's under your statistics. Right, so they're the three things inferential statistics deals with. So calculating the margin of error, conducting a confidence test, and conducting a hypothesis test. So if we go over to our handout, just to kind of fly through what's meant by a couple of things. So the two things that we need to know is sample proportion and population proportion. So sample proportion is quite important. I just need to highlight to you that I just don't want you to have that in your notes. This is actually P with a little hat over it, so that's not a great drawing of it. P hat. Right, okay, so suppose you want to know I'm just going from here. So if you want to know the percentage of Leaving Certs going on to third level education, so you do a survey in your class and you'll ask all the students in your class who's going on to college. So I just have in brackets there that it's not really good indicator, I suppose, as you're only asked to find out how many students are going on after the Leaving Cert, because you're only asking those in your class, you're not asking the whole general population of Ireland who are doing their Leaving Certs. So your survey reveals that 25 out of the 30 students are going on to third level. So to find the sample proportion, you put 25 over 30, and this will give you 0.83 or 83%. Exact same thing. So to find the sample proportion, or this P hat, you just put the 25 over 30. So if there was 196 students were asked if they were going to the shopping centre at the weekend, and 150 said they were, then your sample proportion would be 150 over 196. So it's quite simple. Your sample proportion is denoted by P hat. The population proportion is the whole population. So in this case, Leaving Cert students who go on to third level. P denotes the population proportion. So I suppose we don't know the population proportion, as there's always a chance of error. So we just know population proportion is just defined by P, but we don't have a method of calculating or anything. It's just going to be written as P in our answer. So right, so we'll just go back then to inferential statistics. So that's, I suppose, the important thing to get out of that is how to find sample proportion. But they may ask you to calculate the margin of error, okay? And if they do so, you use this formula here, over here. Okay. Margin of error is equal to 1 over the square root of n. So n is the sample size. So n is the amount of people asked in a survey, or the amount of people that were asked if they went to a shopping centre, all them kind of things. So n just is the amount of people that are asked and the amount of data you have. So what we would do for margin of error, I'll just get my pen here. So if we think of the question, or the sample we had here, so you asked 30 students in your Leaving Cert class, then n is going to be your 30, because that's how many people you sampled. You asked. So we will go, if we find the margin of error there, we would have error equals 1 over the square root of 20, or 30. Because you asked 30 people. So you put that into your calculator, 1 over root 30 equals, and that would be 0.1825. So 0.18 or 18%. So that's your margin of error that you have to account for. Right. So if we look at this example down here, a random sample of 400 people are given a flu vaccine, and 136 of them experience some discomfort. Write down the sample size. So the sample size is the amount of people that were asked and the amount of data you have. 400 was n. That's your sample size. Calculate the margin of error using 1 over root to the n. They're never going to give you the formula. You just need to know it off by heart. You know, to calculate the error, you're going to have 1 over square root of n, which is 1 over root 400. Into your calculator you put 1 over root 400, and that gives you 0.05, which is 5%. So that's your margin of error in this question of the people with the flu vaccine. Right, so then that is margin of error. Just to actually show you, it came up in 2016. It said a few days before the Scottish independent referendum in September 2014, a YouGov poll estimated the support for the No campaign to be 54%. If YouGov sampled 1,000 people, find the margin of error. So their N was equal to 1,000 people. So if we want to find the margin of error, write your answer as a percentage correct to one decimal place. So we have 1 over square root of N, which is 1 over the square root of 1,000. So go back to your calculator, put in 1 over the square root of 1,000, and you will get 0.0316. So as a percentage, so that would be 3.2% to one decimal place. So it's actually quite easy if they ask you that question. Find the sample proportion. So we just spoke about sample proportion, and we said p hat is our sample proportion, and our sample proportion is by putting the 136 people over the 400 people that were asked. So into your calculator, put 136 over 400, that will come to 0.34. So your sample proportion was 34%. Okay? Sometimes your sample proportion will be given to you. They'll tell you the 34%, or sometimes they'll ask you to find the sample proportion. So in this question, the green question here, they asked you to find sample proportion, but if we look down here, a few days before the Scottish independent referendum in September, they estimated the no vote was going to be 54%. So that was our sample proportion. They had already worked it out for us. So next part is the confidence interval. So confidence interval. So this formula here is for confidence interval. Again, it's not in your log tables, but you need to know it. But it is quite simple. So it goes we can read it as sample proportion minus your margin of error less than or equal to p less than or equal to sample proportion plus your margin of error. So you'll have worked all these things. So if we write out, find the confidence interval. So we know our formula is sample proportion minus 1 over root n less than p, which is our population proportion, which we said just stays like that, and then sample proportion plus your margin of error. So we calculate that our sample proportion was 34%, and we subtract our margin of error, which we found was 5%, is less than p less than 34% plus your margin of error, which was 5%. Now you can keep this in decimal form, it's up to yourselves. So that will give us 29% is less than p is less than 39%. So that's just saying to us our confidence interval is between 29% and 39%. So we'll just look at the exam question again. So just to say to you, actually, the confidence error, there's many levels of confidence, but for our course, the only confidence interval that they pitch at is 95%. So when they're talking about confidence interval, they'll always say 95%, but they will say confidence interval with it as well, because I suppose we know that 95% is one of the empirical rule parts as well for 2 standard deviations, so not to get that confused. So if we look at the second part of this, so create 95%, so this is how they'll ask it, 95% interval for the level of no support. So we know that the sample proportion was 54%. We calculated that the margin of error was 3.2%. So now they want us to conduct a confidence interval. So we know our formula is p hat minus our margin of error is less than or equal to p is less than or equal to p hat plus our margin of error. So we'd have 54%, I think it was, yeah, minus 3.2%, less than p, less than 54%,